In mathematics, an integer sequence is a sequence of integers. An integer sequence may be specified explicitly by giving the formula for its nth term, or implicitly by giving a relationship between its terms. For example, the sequence 0, 1, 1, 2, 3, 5, 8, 13 is formed by starting with 0 and 1 and then adding any two consecutive terms to obtain the next one. An implicit description. The sequence 0, 3, 8, 15 is formed according to the formula n2-1 for the nth term. An explicit definition. Alternatively, an integer sequence may be defined by a property which members of the sequence possess and other integers do not possess. For example, we can determine whether a given integer is a perfect number, even though we do not have a formula for the nth perfect number. Examples. Integer sequences which have received their own name include abundant numbers, Baum-Sweet sequence, Bell numbers, binomial coefficients, Carmichael numbers, Catalan numbers, composite numbers, deficient numbers, Euler numbers, even and odd numbers, factorial numbers, Fibonacci numbers, Fibonacci word, figure-8 numbers, Ulam sequence, happy numbers, highly totient numbers, highly composite numbers, home primes, hyperperfect numbers, jugular sequence, Kolakowski sequence, lucky numbers, Lucas numbers, Padyvin numbers, partition numbers, perfect numbers, pseudo-perfect numbers, prime numbers, pseudo-prime numbers, regular paper folding sequence, Rudin-Shapiro sequence, semi-perfect numbers, semi-prime numbers, superperfect numbers, Thursday-Morse sequence, Ulam numbers, weird numbers, computable and definable sequences. An integer sequence is a computable sequence, if there exists an algorithm which, given n, calculates n, for all n greater than 0. An integer sequence is a definable sequence, if there exists some statement p which is true for that integer sequence x and false for all other integer sequences. The set of computable integer sequences and definable integer sequences are both countable, with the computable sequences a proper subset of the definable sequences. The set of all integer sequences is uncountable, thus, almost all integer sequences are uncomputable and cannot be defined. Complete sequences. An integer sequence is called a complete sequence if every positive integer can be expressed as a sum of values in the sequence, using each value at most once.